I've got a late model GM vehicle. We use that as our example. I'm driving down the road, down the highway as a matter of fact usually, and what happens is I step on the throttle and now I've got a bucking sensation, or it kind of hesitates as I'm going to take off. And I've also got an intermittent check engine light. What do you think?
Well, the fact that you've got a check engine light at all means you're going to have to pull the codes.
Okay, I've done that, and what I've come up with on my particular vehicle is a code 21. Where do we go from there?
Well, first of all, find what the code 21 means. You can refer to the manual that you use to work on the type of car that you have, such as this one.
Okay.
And in the code chart section of this book, we find a list of trouble codes. And code 21 in this case talks about a throttle position sensor problem.
Okay. So what we want to do then at that point in time is a quick 2-minute throttle position sensor test, and we'll show you how to do that right now. What we've got on the bench here is the throttle position sensor out of a carbureted vehicle. And really all a throttle position sensor is sort of like a rheostat, or your volume control knob on your stereo. As you push down on this volume control, it increases the resistance or decreases the resistance depending upon your vehicle, and changes the signal back to the computer. And it's got 3 wires that come out of it just like this. All TPSs have those 3 wires. Now testing it's easy.
It sure is. What we'll use is the ohm meter. And what I like to do is turn my ohm meter onto the 20,000 or the 20K scale, because that's a range that gives you a nice big spread of numbers when you're trying to test something that's going to cause numbers to change all the time.
Okay.
Now, since you have 3 terminals here in your throttle position sensor, and I only have 2 alligator clips, you have to remember which 2 to connect to. So take one lead, either the red or the black, it doesn't matter, and put it in the center of the 3.
Okay.
Then use your other lead to get into either one of the other 2 you want. So let's just do this one. Now we're connected to the center and the bottom terminal, and then we can observe the reading on the ohm meter.
Okay, what I'm going to do is actually press down on this little plunger here, and we're going to watch the reading on the ohm meter go up as I'm pushing down on the plunger. And we want to look for a real smooth transition of those numbers, and this one appears to be okay. You want to do that in both directions. Numbers will go up in one direction, back down in the other, and you want to do it relatively slow, because if you don't do it slowly, you could miss a bad spot in there.
You're right, and the important thing is the numbers should follow what you're doing. Nice and slow progression, up and down or down and up.
Okay, this one appears to be okay. So we've checked our throttle position sensor. That is okay. We've still got our code 21. Now where do we go?
Well, if that's the case, we know that there's something else wrong. So you can get into your manual such as this that talks about trouble codes and diagnostic trees, and we can actually find a diagnostic trees for code 21 and the throttle position sensor. So by following the step-by-step diagnostic tree, we're going to arrive at either a bad wire, a bad electrical connection, or maybe even a bad computer. But it's one of those things that's causing the problem on this vehicle.
Okay. Now, on the other hand, we've got another TPS here that we pulled off of a fuel-injected vehicle. Now, it looks a little bit different, but again, it's got our 3 terminal connectors on that. And why don't we run a test on this one, Jim, and see what we come up with here.
Once again, the ohm meter can be left in the 20,000 range. And take one lead, stick it in the center as you're doing.
Okay.
And then you're free to put that one in either of the other 2 you want.
Okay.
And here we have...
Let me see, I got her on there now.
Good. And here we have a reading, so go ahead and operate it just as you did before, and we'll see how this one does.
And we're going up slowly along with my movement, and we'll see. There it is. There's our open circuit, and now look at our resistance is changing again. And we'll come up here, another open circuit.
That's quite erratic, isn't it?
Yeah, it sure is. So that's what's creating my bucking sensation when I'm trying to accelerate, and it's also giving me my check engine light, isn't it?
That's right. This is a bad one, and this is what it looks like. See, the ohm meter is picking up all those bad spots in there.
So hence the reason that you do want to perform this test very slowly, because if you don't perform the test slowly, you go too fast, you could zip right by those numbers and not actually even notice it at all.
Right. Replacing this part would solve your problem.
Sure. 2-minute test, you're down the road again.
Although there are many types of throttle position sensors, they can all be tested by the following procedure. Turn the ohm meter on to the appropriate scale and connect the meter leads to the throttle position sensor. Observe and record the meter reading. Sweep the throttle position sensor through its range of movement. Observe and compare the meter readings as the sensor is swept. If the sensor passes these tests, locate and follow a diagnostic chart for further tests.
Replacing the throttle position sensor, or TPS, on either carbureted or fuel-injected vehicles can be easy with the right tools and our help. There are several different styles of throttle position sensors in use today, but all will resemble one of the styles shown and will be replaced in a similar manner. The tools needed to replace the throttle position sensor on a fuel-injected vehicle include one or more of the following: a set of screwdrivers, a 1/4-inch drive socket set, a set of small Torx bits, and a 10 megohm input digital volt ohm meter. In addition to those tools, you'll need the following to replace a TPS on a carbureted GM vehicle: a 3/32 drift punch, a hammer, a 5/64 drill bit, an electric drill, a number 8 sheet metal screw, a hex key wrench set, a tube of thread locker, a needle nose pliers, and a TPS adjusting tool. To prevent getting burned and to make the job easier, always begin repairs on a cool engine. The first step whenever working on the electrical system is to turn off all electrical accessories, including the ignition key. The first type of TPS we will replace is on a carbureted GM vehicle. Remove the air cleaner assembly to gain access to the carburetor where the TPS is located. Disconnect the MC solenoid and TPS electrical connectors from the carburetor. Disconnect the upper choke lever from the end of the choke shaft by removing the retaining screw. Remove the lever from the choke rod by rotating it until it disengages from the rod. Remove the choke rod from the lower lever inside the main body casting by holding the lower lever outwards with a small screwdriver and twisting the choke rod. Using a 3/32 drift punch and hammer, drive the accelerator pump lever pivot pin inward until the end of the pin is against the air horn. Lay the pump lever off to the side and out of the way, and using a needle nose pliers, remove the TPS plunger. Using a needle nose pliers, remove the vacuum hose from the choke pull-off. Now, remove the 2 front carburetor mounting bolts with the ratchet wrench and socket. Unscrew the center mounting stud for the air cleaner. Remove the air horn to main body screws. When removing the 2 countersunk screws located inside the air horn, use a magnetic screwdriver to prevent dropping them into the intake manifold. If you are uneasy about removing these screws with the carburetor on the engine, we suggest you stop here and remove the carburetor from the intake manifold before proceeding any farther. Remove the air horn from the main body by lifting it straight up and off. Pushing up from the bottom with a small screwdriver on the electrical connector, remove the TPS assembly from the main body. Using a needle nose pliers, retrieve the spring from the TPS well. Compare the old TPS with the new one to be sure of the correct replacement. Install the new TPS spring. Position the new TPS assembly into the carburetor main body. Be careful to align the groove in the electrical connector with the slot in the main body casting. Push down on the electrical connector and the sensor so the wires and the connector are below the main body casting surface.